Hello guys, in this video we are going to discuss about the tricks of Newton's laws of motion. So this is the part 2 of the series of videos for NEET and JEE. So while watching this video you can solve for acceleration of blocks in an inclined plane in seconds. So again, welcome to IB360. So over here in this video, we'll find the acceleration of the blocks that are kept in an inclined plane in seconds. So by watching this video, you can find the acceleration of these systems within a matter of seconds. So let's start. So proceeding on to the first concept, we'll see how to find the acceleration of the blocks in an inclined plane when the angles of the inclined plane are same. So over here we have an inclined plane and the angles of the inclined plane are same, right? So that means over here this angle is theta, and over here this angle is theta, and we have two masses, one of mass m2 and the other of mass m1, which are connected by a single string. So the concept over here is that when the angles of the inclined plane are same, see over here this angle is equal to this angle, right? So that means the angles of the inclined plane are same. So that means what will happen now, the heavier mass will move downward and the lighter mass will move upward. So as m2 is the heavier mass than m1, m2 will move downward or away from the pulley and m1 will move upward or towards the pulley. So now the blocks that are going away from the pulley will give us the pulling force, and the blocks that are going towards the pulley will give us the resisting force. Over here we saw that m2 will go downward, right? So that means, see, this is the pulley, right? And m2 is going downward, right? So that means away from the pulley. So that means the block that are going away from the pulley will give us the pulling force. As m2 is going away from the pulley, it will give us the pulling force. Now over here, see that as m2 is moving downward, m1 is moving upward, right? So that means this is the pulley, m1 is going upward, or that means towards the pulley, right? And the blocks that are going towards the pulley will give us the resisting force. So that means over here m1 will give us the resisting force. So let me summarize this important concept. All the blocks that are going away from the pulley will give us the pulling force. m2 is going away from the pulley, so m2 will give us the pulling force. And all the blocks that are going towards the pulley will give us the resisting force. m1 is moving towards the pulley, so it will give us the resisting force. Now over here the magnitude of the pulling force is given as mg sin theta. So over here, see that m2 will provide us the pulling force, right? We have discussed earlier. So over here the block of mass m2 is sitting on an inclined plane of angle theta degree. See, this is the block of mass m2 and this is the angle theta degree on which it is sitting. Okay, so that means the pulling force provided by this m2 block will be what? m2 g sin theta degree, right? In the place of m we are substituting m2, and in the place of theta we are substituting theta degree, right? And over here the value of the resisting force will be also mg sin theta. Okay, over here the block of mass m1 will provide us the resisting force we have discussed earlier, right? So that means this block of mass m1 is sitting on an inclined plane of angle theta degree, right? So that means the resisting force will be m1g sin theta degree, right? In the place of m we have substituted m1, and in the place of theta, that is the value of the incline, we have substituted theta degree. So that means the pulling force is m2g sin theta degree and the resisting force is m1g sin theta degree. So that means the acceleration will be the total pulling force minus the total resisting force divided by the total mass. Total mass, capital M. Now what will be the total mass? Total mass will be this block, that is your m2 plus your m1. Okay, so that means the total mass will be m1 plus m2. So over here we can put all the quantity and solve for acceleration. So let us start our first example. We will see how with the help of a simple formula we can find the acceleration of this system in seconds. So over here in this figure you can see that there are two masses, one of mass 3 kg and the other of mass 2 kg, which are connected by this single string. Okay, and both the 2 kg mass and the 3 kg mass are placed on an inclined plane of angle 30 degree. So we need to find the acceleration of the 3 kg mass and the acceleration of the 2 kg mass. Since the 2 kg mass and the 3 kg mass are connected by a single string which passes over the pulley, we can say that the acceleration of the 3 kg mass will be equal to the acceleration of the 2 kg mass. So over here you can see that the 3 kg block is greater in mass than the 2 kg block, right? So that means this side is heavier compared to this side. So what will happen? The 3 kg block will move away from the pulley and the 2 kg block will move towards the pulley. So that means the 3 kg block is going downward and the 2 kg block is going upward. Now suppose the downward acceleration of the 3 kg block be A. So that means the upward acceleration of the 2 kg block will be also A. Why? Because the acceleration of the 3 kg block is equal to the acceleration of the 2 kg block. right? Now over here the pulling force will be provided by the block which is going away from the pulley, right? So that means this is the pulley and this 3 kg block is actually going away from the pulley, right? So that means the pulling force will be provided by the 3 kg block, and in an inclined plane the pulling force is what? mg sine theta. So that means over here this 3 kg block will provide us the pulling force. In the place of mass we'll put 3g, and what is the angle? Theta. Theta is 30 degree, right? So that means the net pulling force will be 3g by 2, and the resisting force will be provided by the block which is actually going towards the pulley. See over here this is the pulley and the 2 kg block is actually going towards the pulley with an acceleration of a. So that means the resisting force will be provided by this 2 kg block, and what will be the value of this resisting force? mg sine theta, right? So this 2 kg block will provide us the resisting force 2g sine 30 degree. Why 30 degree? Because this angle is 30 degree, right? So that means the over here the resisting force will be g. So that means for this system the pulling force is 3g by 2 and the resisting force is g. So what will be the acceleration? Acceleration will be pulling force minus resisting force divided by total mass. Now what is pulling force? That is your 3g by 2 minus resisting force. The resisting force over here will be g divided by the total mass. So over here you can see that there is a 3 kg block and there is a 2 kg block. So over here the total mass will be 3 plus 2, that means your 5. So that means the total mass will be 5. So from here the acceleration comes out to be g by 10. So that means the 3 kg block will move downward with an acceleration of g by 10 and the 2 kg block will actually move upward with an acceleration of g by 10. So proceeding on to the second example, we'll see how with the help of our formula we can find the acceleration of this system in a matter of seconds. Here in this figure again you can see that there are 3 blocks. One of mass 2 kg, one of mass 3 kg and the other one of mass 2 kg. The 2 kg mass and the 3 kg mass are connected by a single string which passes over the pulley, and the 3 kg mass and the 2 kg mass is connected by this single string. So over here you can see that this 3 kg mass and this 2 kg mass is placed on this inclined plane of angle 30 degree, and this 2 kg mass is also placed on this inclined plane of angle 30 degree. So over here you can see that this 2 kg mass and this 3 kg mass is actually connected by a single string. So that means the acceleration of the 2 kg block will be equal to the acceleration of the 3 kg block, right? So that means acceleration of the 2 kg block will be equal to the acceleration of the 3 kg block. Again you can see that this 3 kg block and this 2 kg block are actually connected by a single string, right? So that means the acceleration of the 3 kg block will be equal to the acceleration of the 2 kg block, right? So that means acceleration of 3 kg will be equal to the acceleration of the 2 kg block. So in conclusion I can say that the acceleration of the 2 kg block will be equal to the 3 kg block will be equal to the 2 kg block. So over here you can see that this side is actually much heavier than this side. Why? Over here in this side there is a 3 kg block and there is a 2 kg block, but over here in this side there is only a 2 kg block, right? So that means obviously this side is much heavier. So that means the 3 kg block will move downward, that is in the direction away from the pulley. Similarly the 2 kg block will move downward, that is in a direction away from the pulley, and the 2 kg block will move towards the pulley, that is your upward. Now let us suppose the downward acceleration of the 3 kg block be a. So that means the downward acceleration of the 2 kg block will be also a. Why? Because the acceleration of the 3 kg block is equal to the acceleration of the 2 kg block. Okay, and the upward acceleration of this side 2 kg block will be also a. Why? Because the acceleration of the 2 kg block is equal to the 3 kg block. So we know that all the blocks that are moving downward or away from the pulley will provide us the pulling force, and all the blocks that are moving upward or towards the pulley will provide us the resisting force. Now over here you can see that the 3 kg block is actually moving downward, right? So that means it is actually moving away from the pulley. This is the pulley, the 3 kg block is moving away from the pulley. So that means the 3 kg block will provide us the pulling force. Over here the 2 kg block is also moving downward, that is away from the pulley, right? So that means this 2 kg block will also provide us the pulling force. So over here the pulling force will be provided by the 3 kg block plus the 2 kg block. Now the 3 kg block will provide us the pulling force mg sine theta. In the place of m we'll put 3, right? So that means 3g sine 30 degree, because the angle of the incline is 30 degree. And the 2 kg block will provide us the pulling force as mg sine theta, right? And in the place of m we'll write 2, so that means 2g sine 30 degree. Again, as the angle is 30 degree, so theta will be 30 degree. So that means the net pulling force will be 5g by 2. Over here, see that this 2 kg block is actually moving in the upward direction, that is towards the pulley. And we know that all the blocks that will move towards the pulley will provide us the resisting force. Now the resisting force provided by this 2 kg block will be what? Mg sine theta, right? And in the place of m we'll put 2 multiplied by g multiplied by sine theta. Now what is theta? Theta is the angle of the incline, which is 30 degree. So that means sine 30 degree. So from here the resisting force will come out to be g. So that means the pulling force is 5g by 2 and the resisting force is g. So what will be the acceleration? Acceleration will be total pulling force, that is your 5g by 2, minus the total resisting force, that is your minus g, divided by the total mass. Now over here the total mass is 2 kg plus 3 kg plus 2 kg, right? So that means 7 kg. So that means the acceleration comes out to be 3g by 14. So that means the 2 kg block will move downward with an acceleration of 3g by 14. The 3 kg block will move downward with an acceleration of 3g by 14. And the 2 kg block will move upward with an acceleration of 3g by 14. So proceeding on to the second concept. In the second concept, we will see when the angles of the inclined plane are different, how can we find the acceleration of the system? So before proceeding further, we need to discuss some few concepts. So over here in the previous examples, we saw both the angles of the incline were same. Right. Now suppose the angles of the incline are different. So suppose one is 30 degree and the other is 60 degree, and we have a 3 kg mass and a 2 kg mass. Okay. So in the case where the angles of the incline were same, we can directly say that the 3 kg mass was greater than the 2 kg mass. So that means the 3 kg mass will move downward and the 2 kg mass will move upward. Right? But in the case where the angles are different, okay, so over here angle is 30 degree, over here angle is 60 degree, right? So that means the angles are different. Over here we cannot directly say as the 3 kg is greater than the 2 kg, it will go downward or it will go upward. Over here we cannot directly say that. So in order to solve this kind of problems where the angle of the incline are different, we have to assume that the motion will occur down the right incline, right? So that means this is the left incline, this is the right incline, right? Down the right incline means this direction, right? So we have to assume the motion will take place in this direction, right? So that means the 3 kg block will move down and the 2 kg block will move up. Okay. Now on solving, if the acceleration comes out to be negative, then the acceleration will be in the opposite direction. Okay. So see, from the first point we have assumed that the 3 kg block is moving downward and the 2 kg block is moving upward. Right? Now on solving for the acceleration of this system by the first assumption, if the acceleration comes out to be negative, okay, so suppose the acceleration comes out to be negative, it comes out to be minus g by 10, then what will happen? Then the acceleration will be in the opposite direction. We assume the acceleration to be in this direction, right? Now if the acceleration comes out to be negative, then it will be in this direction. That means the 3 kg will move up and the 2 kg will move down. So we will discuss this example in detail and your concepts will become crystal clear. So proceeding on to the next example, we'll see how with the help of our previous formula and a little concept, we can find the acceleration of the system where the angles of the incline are different. In this example, there are two blocks 3 kg and 5 kg connected by a single string which passes over the pulley, and the angle of incline is 30 degree and 60 degree in seconds. So over here, as the 5 kg block and the 3 kg block is connected by a single string which passes over the pulley, acceleration of the 5 kg block will be equal to the acceleration of the 2 kg block. So now over here, see that as the angle of the incline are different, one is 30 degree and the other is 60 degree. We cannot directly say as 5 kg is heavier than 3 kg, the 5 kg will move downward and the 3 kg will move upward. We cannot directly say that. So we have to solve with the help of our previous concept. What was our previous concept? See, this is the left incline, this is the right incline, right? We have to assume that the motion will happen downward in the right incline, right? So that means we have to assume that the 3 kg block will move downward and the 2 kg block will move upward. Again explaining, we have to assume that the motion will take place downward in the right incline, right? So this is the left incline, this is the right incline, the motion will be downward, so that means in this direction in the right incline. Okay, so that means the 3 kg block will go away from the pulley and the 5 kg block will move towards the pulley. Okay, and we know that all the blocks that are moving away from the pulley will provide us the pulling force, right? So over here the pulling force will be provided by the 3 kg block. Why? It is moving away from the pulley, right? So that means the pulling force will be provided by the 3 kg block, and what will be the value of the pulling force? Mg sin theta, right? And in the place of m we'll write g, so that means 3 times g times sine theta. Over here theta will be the angle of the incline on which the 3 kg is sitting. The 3 kg is sitting on the right incline, which has an angle of 30 degree. So that means sine 30 degree. So over here the pulling force will be 3g by 2. So that means the net pulling force is nothing but 3g by 2. Now over here you can see that the 5 kg block is moving towards the pulley, right? And we know that all the blocks that are moving towards the pulley will provide us a resisting force. So that means the resisting force will be provided by this 5 kg block. And what will be the value of the resisting force? Mg sin theta, and in the place of m we'll put 5. So that means the resisting force will be 5g sine theta. Now theta is the angle of the incline on which the 5 kg block is sitting. The 5 kg block is sitting on the angle 60 degree, right? So that means mg sine 60 degree. So from here the resisting force comes out to be 5 root 3 g by 2. Over here 3g by 2 is nothing but 1.5 g, and over here 5 root 3 by 2 g is nothing but 4.33 g. Okay, so that means the acceleration will be the total pulling force, so that is 1.5 g minus total resisting force, that is minus of 4.33 g, divided by the total mass. Now over here the total mass will be 3 kg plus 5 kg, so that means your 8 kg. So that means the acceleration will be minus 0.35 g. Now over here see that the acceleration comes out to be minus 0.35 g. So that means the acceleration is negative. So whenever in the case of different angles of the incline the acceleration comes out to be negative, so that means our initial assumption was wrong. What was our initial assumption? That the 3 kg will move downward and the 5 kg will move upward. So this assumption will be wrong, and actually what will be happening is that the 3 kg block will move upward and the 5 kg block will move downward, which is just opposite to our initial assumption, right? So that means the net acceleration of the 3 kg block will be up the incline, and the value of the acceleration will be 0.35 g. Okay, and the 5 kg block will actually move down the incline, and the value of that acceleration will be 0.35 g. So proceeding on to the last and the final example, we'll see how with the help of our previous formula and a little concept we can find the acceleration of the system where the angles of the incline are different in seconds. So let us take another example. Over here in this example there is a 10 kg block and a 5 kg block, and the angles of the incline are 30 degree and 60 degree, right? So again, as the angles of the incline are different, we cannot directly say that as the 10 kg is greater than the 5 kg, it will move downward and the 5 kg will move upward. We cannot directly say that. Okay, so first of all, as the 5 kg block and the 10 kg block are connected by a single string, we can write that the acceleration of the 5 kg block will be equal to the acceleration of the 10 kg block. Okay, now what we need to do is that again, so this is, see, this is the left incline and this is the right incline, right? Now we have to assume that the motion will take place down the right incline, right? Now what is the direction down to the right incline? So see, this is the right incline, so the direction down to the right incline will be this, right? And we have to assume the motion takes place in this direction. So that means we have to assume that the 10 kg block is moving away from the pulley and that 5 kg block is moving towards the pulley. Okay, so as the 10 kg block is actually moving away from the pulley, the 10 kg block will provide us the pulling force, and as the 5 kg block is moving towards the pulley, the 5 kg block will provide us the resisting force. And let us suppose the acceleration of the 10 kg block be a, so the acceleration of the 5 kg block block will be also A. So that means the net pulling force will be provided by the 10 kg block. And what will be the value of the pulling force? Mg sin theta. And in the place of M we'll write 10. So that means 10 times G times sin theta. Sin theta. Now what is the theta? Theta is the angle of the incline on which the 10 kg block is sitting. The 10 kg block is sitting on the 30 degree incline, right? So that means sin 30 degree. So that means the pulling force will be 5G. Now over here the resisting force will be provided by the 5 kg block as it is moving towards the pulley, right? And what will be the value of the resisting force? Mg sin theta, and in the place of M will write 5. So that means it will be 5 times of G times of sin theta. Now what will be theta? Theta is the angle of the incline on which the 5 kg is sitting. The 5 kg is sitting on the 60 degree incline, right? So that means sin 60 degree. So this will be equal to 5 root 3 G divided by 2, which is nothing but 4.33 G. So that means the pulling force is 5 G and the resisting force is 4.33 G. So that means the acceleration will be the total pulling force, that is your 5 G, minus total resisting force, that is your 4.33 G, divided by the total mass. Now what is the total mass? 10 kg plus 5 kg. So that means this will be 15. So over here acceleration comes out to be, now over here one thing that you need to know is that acceleration over here came out to be positive. In the previous case acceleration came out to be negative, but over here the acceleration comes out to be positive. So what does positive acceleration mean? Positive acceleration means the direction we have chosen in our assumption is right. So that means our initial assumption will be right. Okay, so that means the 10 kg block will indeed go downward and the 5 kg block will indeed move upward. Okay.